All right, example 7 is extra, and it is kind of just that. It's a little bit extra. It's a little more challenging than what we've been seeing, but it's kind of fun to see if you can still use your trig and the information that they give you to solve it. So it says here, Francisco needs to know the height of a tree. From a given point on the ground, he finds that the angle of elevation to the top of the tree is 36.7 degrees. He then moves back 50 feet. From the second point, the angle of elevation to the top of the tree is 22.2 degrees. Find the height of the tree to the nearest foot. So they do actually give us a little diagram here, which is nice, so that we can use this diagram and kind of set up what we know using the information in the word problem and the diagram that they give us. So it looks like in this problem, we are trying to find the height of the tree. It looks like in our picture, they have labeled this height h. We know that Francisco kind of walked. He had an angle of elevation to the top of the tree that was 36.7 degrees. Now I'm going to assume that this tree is straight up and down, so it looks like we have here a right triangle, right? Where the tree height they're calling h, and the distance from the base of the tree to where Francisco first stopped, they called it x. So I always like to draw a separate picture that's kind of separate than the one that's given, so I can clearly see what's happening in that little triangle, right? Now, Francisco walked back a little bit more and measured again, right? He walked back another 50 feet, and then it said here the angle of elevation to the top of the tree now is 22.2 degrees. Now, if I look, I have another larger right triangle with some given information. The height of the tree is still h. The angle of elevation is 22.2, but what would we now call this whole distance from the base of the tree to where now Francisco is standing at the very end? It's not just 50, it's not just x, but what we could do is we can draw a new triangle and label that whole distance 50 plus x, right? So now I have two separate right triangles. Let's look a little bit more at these two right triangles. Remember, our goal is to solve and find the height of the tree. Now, if I'm looking at this smaller right triangle, it looks like I know the side that's opposite of the angle 36.7 degrees, and I know the side adjacent to that angle. So which trig function puts the opposite and adjacent side together in a ratio? Right? That would be tangent. So we can set up a tangent equation that says that tangent of 36.7 degrees is equal to the opposite side, which is our h, over the adjacent side, which they're calling x, right? Let's do the same thing for the other triangle. It looks like on the other triangle, I also know the opposite side and the adjacent side. So let's set up another tangent ratio for the angle of 22.2 degrees. We know that tangent of 22.2 degrees is the opposite side, h in this case, over the adjacent side, which is 50 plus x. Okay. Now again, remember, we're trying to solve for h. So in each of these little equations, if we want to try to get h by itself, over here on the right equation for the smaller triangle, I can multiply both sides by x, reduce those x's, and I would get a new equation that says h equals x times the tangent of 36.7 degrees, right? Let's do something similar in the other equation, trying to solve for h, getting h by itself. So let's multiply both sides in this equation by 50 plus x. The 50 plus x on the right side should reduce, and then I'm left with an equation that says h equals 50 plus x times the tangent of 22.2 degrees, right? Now, a little bit tricky because now we have two different equations and we're trying to solve for h in both of them, but we don't know what x is. But we do know that h is the same in both equations. If I have an equation over here that says h equals, and I have an equation over here that says h equals, can't I set those two equations equal to each other since they both equal h? So that's what I'm going to do. I'm going to take my two equations that both equal the value of h and set them equal to each other. Now that'll help me solve for the only variable that's left, which is x now in my new equation. Okay, using some algebra, I'm going to take this tangent of 22.2 degrees and multiply it by 50. I'm also going to distribute and multiply it by the x. So on the left side, I have 50 times tangent of 22.2 degrees plus x times tangent of 22.2 degrees. On my right side, I have my x times tangent of 36.6. Now, if you're looking carefully, you have a variable here, you have your variable here, and so I have two x's, but they're on opposite sides. My goal is to try to get x together onto the same side and isolate for x, right? Solve for x. So I'm going to take this tangent, this x tangent of 22.2, and what I'm going to do is I'm going to move it over to the other side by subtracting. Right? I'm going to move it over to the right side by subtracting it. When I do that, I now have a new equation. Might want to pause for a second and write down your new equation. You should have a 50 times tangent of 22.2 degrees is equal to x of tangent of x tangent of 36.7 degrees minus x times tangent of 22.2 degrees on that right side. Now again, here's our variable, right? I have x's now on the same side, and since both terms on that side have an x, they have a common factor, so I can GCF out, greatest common factor out, that x, and then I would have the quantity tangent of 36.7 degrees minus tangent of 22.2 degrees, which is just some number, right? Over on my left side, I still have the 50 times tangent of 22.2 degrees, which again is just a number, right? That's kind of like having 4 equals x times 2. We want to get x by itself. If we want to get x by itself and we need to get rid of something that's being multiplied by x, how can we do that? Well, we can simply divide both sides by that quantity. I can divide both sides by this tangent of 36.7 minus tangent of 22.2. That will allow me to isolate x and get x by itself, and then I just have to figure out what this number is using my calculator. So pause the video for a second, put that in your calculator, make sure that you're in degree mode, and let's figure out what x equals. I ended up getting x equals 60.4967520, and it keeps going and going and going. Now be careful. If you remember back in our word problem, we're not necessarily trying to solve and find x. Aren't we really trying to find h, the height of our tree? But if we know x now, then what we can do is use that information and either plug it into this equation in order to find h, or you should be able to plug it into this equation in order to find h. Remember, it's the same h, so no matter which equation you choose, if you plug x into either one of those, you should end up getting the same answer for the height of your tree. Try it and see what happens. I ended up getting h is 45.09. The question says to the nearest foot, so I'm going to say that the height of that tree is approximately 45 feet tall. Hopefully you got the same answer as me. Whew, that was kind of a good one, right? Being able to look at the information, the picture that they gave you, be able to set up your own right triangles and use trig in order to solve.